Hello and welcome everyone. This is your host Farid Pasha signing in from Toronto, Canada. And today I'll be giving a brief introduction on how I normally work with graphics and images in the Wolfram language. I've tried to keep this session slash demonstration on a very basic level, and the main objective is that when users like you will be developing certain graphics and images using Mathematica, uh, how aesthetically you can present that while converting that into either slideshows or developing journal papers or research articles. What small tips which are very useful, and we sometimes overlook that when we are working in the deep R&D using Mathematica. So that is the main objective of how I'm going to use this session today. So as we proceed, you can see I'll be giving a brief introduction of how the graphics and images are created in Wolfram language. We'll see some tips and techniques for customizing graphs, which include styling and formatting, which plot themes are available over here, and then how you can size and position your images or graphs, specifically when you are assembling those images together, like making an image collage or something like that. Then we will also look at some of the examples of how you can extract data like coordinates and the regions out of those images and graphs. And in the end, we will try to combine all of these together to see how we can prepare these images and graphs for publications. And in the end, we will take a quick look on 3D printing functionality, which is available in Wolfram language. So if we quickly start, we can see that what are the different ways of creating graphs and images. And the most common one is to, first thing to do is to import an image into the notebook. And there are different ways you can do that. Like you can do drag and drop option also. So basically what you will do, you'll just, if you have some image like here, I have this image of my picture, I can just drag it into my notebook. And then I can start using this image for analysis. Like maybe if I say I want to do like a color negate of this image, I can do that. Or maybe you say, okay, I want to blur this image by a certain parameter, and then you can do that. So the easiest way is to just drag and drop your image into the notebook as well. Another option can be using the built-in camera. So you know there is a command in Wolfram language which is called current image. So basically what current image will do is just take in your camera and will take the input for that. So it takes the current input at this right stage at this time. And then I can save it as an image, and then I can also do the same computations on that, on this also. So maybe I say, okay, for this image, I want to do like a edge detect. So once I have the image in my notebook, I can do that. So normally what I normally like is to do device close, and it is using my camera. So I close this camera. So one option is to drag and drop. The other will be like using built-in camera. So why I'm doing this is just in the end, then I'll be saving this file for sharing, and it will be ready for that. Another way we can do and get the picture file into that is we have another function called image capture. So what image capture will do is basically, if I uh, start the camera, so basically now it's taking the live input like a video image on that, and whenever I click this capture frame to notebook, it will just take a picture of that specific image. So once I click this, you say now it has taken the picture for that. So this is also an easy way to get the image into Wolfram, into your notebook as well. So let's again close this. So the both easiest ways of these things are to just taking by the image capture or a built-in camera like the current image over here. Another thing you can do is you can do web search. So I'll say with web search, and what the web search will do is basically, let's correct this one. So with the web image, what will happen? It will go and search the images in the web. So for that, we have a function called web image search. And when I can give it any function, like, and I can say like tigers. And then it will go and it will search the internet, and it will fetch in the top 10 images which are classified under the tigers. So by default, it will take in the 10 images. And you can make this more interesting, like maybe tigers in Africa, and it will then try to search those images in the which are like classified with the title of like having in Africa. And then you can save those images, and then you can utilize that. Maybe let's use it like eggs. And it will go and bring me the 10 images which are related to eggs over here. So more thing, if you want to learn about that, you can go and in the documentation center, you can look about like web image search, and you can get more information from here. Like this is the command I did, web image search tiger, so it gave me 10 tigers for that. If I say beer and then I mention a 3, so that means it will not give you now 10, it will limit the results to 3 images. And then you can definitely, once you have the image in your notebook, you can perform certain more functionalities or more algorithms, or you can apply on that. So I will recommend you go and study web image search in the documentation center as well, because that will give you more information of how you can search those images directly and get those images into your notebook as well. One another way you can also like import your images in your notebook is to just specify the file name also. Like you can, using the import command, you can use that. So maybe you want, if you have your file saved into the same thing, and you can say, okay, like import function, then you can use and just give the place and the location where your images or your image is located. So you go to the insert, and you can select the file path from here, and maybe at the desktop you can see which are the images file available over here, and then you can just give the location image path of that file, and then that is now imported into your notebook. So you can do this programmatically by giving the location where your file or the image is present. Another way you can also do import is just giving by the direct URL. So for example, you have certain so let's convert this into so that we can minimize this. We can also minimize this. Another option we can do is by giving URL. So what by URL means is like if you know where the location of your image file is on the internet. For example, maybe if I am not wrong, I know that on wolfram.com at the common I have this framework, and then there is an image of spiky is available over there, and it's in a PNG format. So if you know the exact URL, you can just give that URL into the this. This can also be done like if you go and Google it, and then you can right click on those images. You also get the image location from there as well, and then you can take those uh, URL address from there, and then utilize that and to import your image into the notebook as well. So once you have the this is all about getting and importing your image into your notebook. The other thing we can do is now how we can do some styling and customizing of the charts as well. So one thing which I want to tell you more about is using plot themes. So there are plot themes available in Wolfram Language, which provides styles for charts and plots, and they give a customized appearance. So for example, if I have this data range of 5 maybe, and I want to have a bar chart 3D of this data. So but if I choose some plot theme, and you say it automatically gives me the option which plot themes are available over here. So auto completion menu appears as you are typing, and you can see what are the differences between these, like web, minimum, detailed, business style, marketing style, scientific, monochrome. So there are many options which are available over here, and you can just click or type in anything from here, and then you can execute this, and you can see what type difference are there available over there. And then there you can add on more features into that as well, because this allows you to add certain feature themes to the base theme as well. So for example, you are using a detail, but you can add more features into that. So maybe I say, okay, I want to add like a cool color, and then maybe I want to add more like large labels. So you can, so this is the base theme. So detailed will be the base theme, how the theme looks like. And these are more feature themes, so which are associated with this detail, and then you can have more customized plot based on that. Another way you can do is by using some built-in palettes as well. So by using palettes, let's type by using palettes. So one is by plot theme, and the other is palettes. So palettes is like if I'm doing this same bar chart 3D, and it's for a range of maybe 10 this time. So if I do like a comma over here, and then if I go into the palettes, so in the palettes you will see there is like a chart element scheme palette over here. So if I click on this, a palette will open up for me, so which has more options available, which I can select the type of the chart I'm customizing. So I'm using a 3D chart, so I'll just use select, it's auto selected as 3D, and currently it's using chart element type of cube. But if you want to change some other to some other feature like segment scale cube, you can click that, and you see the option preview is also coming on the downside as well. And you can just adjust the parameters of the style. You say I don't want to have like 5 segments in them, you maybe have less segments or like more segments to do that. How you want to change the colors, or you can have some other color scheme. You can adjust the appearance parameter basically from here directly. And once you have are satisfied with what the appearance of is that look like, you just see there's a button called insert option. You can just click insert option, and all those uh, features are now directly into your notebook represented over here. And then you can just reevaluate it, and you can see now all those chart element function types are now displayed into that. So we'll come more about zooming in, zooming out, and the rotation of 3D and 2D graphs later in my presentation. But this is another way you can customize your charts by using built-in palettes. So another way how you can customize your chart is you would like to maybe change the scale basically, or alter the axis or on a plot to better represent the data. And because the main theme of these plots is to show to your viewers the relationship between those things. So how the parameters change and look. So that is the important for that, and for that we sometimes need to present our plots in a more aesthetical manner. So maybe I'll just like import the data over here. So I'll use a built-in resource data object, which is sample data of mercury vapor pressure. So I'm using the built-in data resource, and now once I have this data available into my notebook, then I can use the functionality to visualize this data. So maybe I want to visualize this data and do the list plot of this data. But now to make it more presentable so that your viewers can understand what this plot shows, you need to show certain relationships using linear scales on both the axes. And then you can like say that, okay, my axis label are, and then you can define your label like temperature on the x-axis and pressure on the y-axis. So it's now displayed, and then maybe you say, okay, I also the point size are very small over here, so I will also have a function called point size. Oh, plot style, sorry, it's built into plot style now, and then I can say that the point size I want to use is large. You can also give some specific value like 10, 20 for what size you want to do, but large, medium, and tiny and small, these options are available also here. But you will also see that the relationship between pressure and temperature appears to be nonlinear. So a different scale can be used to get a better visualization for that. And for that, in the plot, we have another feature which is called the scaling functions. So I can directly have like scaling functions. I can have a log, reciprocal, log 10, or log 2. So I think maybe log will be much better representation of the relations. And then maybe you can add some more features like joint is true. So basically it will make all the points join together. But now you see the individual points are not visible. But you say, okay, that is an important feature. You want your viewers to see that. So you can have like mesh to show that. And now you see all of these like is available over here. So these two like joins the plots together, but they keeps the original location as well. And then using the scalar function, you can have a log, or you can if you say, okay, this I do not want to have a log, I want to have a log on both, like for the x-axis operation and the y-axis. So currently this is only doing for the y-axis, but you say no, I also want to see the relationship when the scaling function is log for both x-axis as the y-axis, like pressure and temperature in this scenario. So I can just change this into a list, and I can say, okay, give me the log for both x-axis and y-axis. So this log will be for the x-axis operation, and this log will be for the y-axis operation. And I think this makes the visualization more clearly, which shows the general relationship between temperature and pressure to your viewers at this time. So another thing which we can look into that is how do you change the scale on points for in a 2D scatter plot as well. So some other things which you can do is, let me change this format from to the working so that it should be more viewable. Let's okay. So maybe I'll take another data which is like let's create a table quickly where I'll have I and then add it to a random real number between 5 and then maybe make this I go from to 20. So we'll have this data available, and then we can have the list plot of this data. And then you see the plot markers at this time. Marker style is different, so maybe I can say like maybe do plot markers and keep them automatic at this time and see how we vary them, and then we'll see the changes how they do that. But you might have noticed that just by making it automatic, the marker styles have these points have get slightly larger points than before. But you can use a preset set value as well. Like you can say this should be like automatic, but I also want these to be like medium. So this is the marker size now, which is mentioned over here. Or you can give it a numeric size value as well. You say, no, this is still small, maybe a little bit more, like a 20 or something like that. You can give the marker style. You can also change the shape of these markers. So you say, no, I don't want these to be automatic. I want to have a specific shape. Maybe this is the shape of my points. Or maybe this is the shape of my points. Then you can give those plot markers specific shapes as well. So you can use a corrector to mark those plot points. Even you can have some graphics over here to do that. Maybe you say, okay, let's make this graphics of, and let's have a triangle over here, and the size of the side can be like 0.1 maybe. So you can have any type of feature added into the plot markers which you think is more suitable or more better illustrate your representation. So these are very small tips and techniques which are very useful most of the time, which you can use to make your graphs and images more aesthetically and presentable. And then you can also change the color for that as well. So maybe you say, okay, this is marker color should be like these triangles should be red over here. So you can just add another plot feature over here that plot style should go to be red. And you see, before you are going in, it gives you the options like how you want to autofill those things. And then the plot style can be done into red. And you can differentiate multiple collections of data using multiple different plot markers as well. So for example, if you have another data set like more data, and then maybe what we do is generate this same one over here, but here I have 2i, so I have a different set of data. And then I can have like a list plot of both of these, like data and more data together, and I'll have plot markers, and to differentiate between those, I say, okay, the first one should be like have this marker point, and the second one should have this marker point. And I also want to differentiate those colors as well. So I said the first one should have a red color and the other one should have a blue color. So you said I can differentiate multiple collections of data now using custom plot markers as well. So this is for the first data set. So data, so this is for the first, and correspondingly this will be for the first and this will be for the first data set. Similarly, this is the second data set, and in this option this is the second, correspond to this, and blue correspond to this. So you can differentiate multiple collections of data also using these style points in 2D scatter plots as well. Okay. Any questions? Feel free to write into the chat, and I'll take a look also on that. Other thing I want to share with you is how you can custom do your sizing and positioning of your graphs as well. So there are also multiple ways you can do that. So let me go back to this screen environment into slideshow. Okay. So for example, I have a graphic, maybe, so let me copy paste an image over here. So maybe I have this graphic over here. So now there are different ways you can handle the drags and drops. So there are a couple small tips over here. So if you click on this, you see it has now the highlights the drag handlers over here, and these drag handlers behave differently once if I move it with the shift key pressed and without the shift key pressed. So if I just drag the handle at this now without doing anything, it will keep the aspect ratio of this similar, and just make the sizing of the graph. I can like drag and the handle to resize it. So, but if I use like drag the handle now by pressing like a shift key, now the aspect ratio of a graphic will be changing when I'm doing that. So this is while I'm doing it with the shift pressed in, and when I drag this, you see the ratios are now being changed also when I drag the handle. So these behave differently with the shift sign in and without the shift sign. Another way you can also resize and manage the sizings of your graph is by managing it programmatically. So you specify the size of the graphics output. So maybe you say, okay, I want to have a graphics of a disk. So, but you want to have this a specific image size. So you can give that as an image size over here. And then you can either choose it from the pre-built functions like tiny, small, medium, large, full, or you can give the exact widths in pixels as well. So I say, okay, I want it to be for 100 pixels. So you can just mention it over 100. So now whenever this image will be popping out, the image size will be fixed, and you cannot resize that to that. So maybe you say, okay, no, I want to have this a little bit bigger, or any other value you want to give. So you can manage the resizing of the graphics by either dragging the handlers or by using programmatically as well. So you can see when I right click on this, it gives me some. So if I can make it like a standard size, so this will be more the standard size. You can also convert that directly by right clicking on that and doing that. But if you want to have like a image which is like equal to the notebook image length, you can just say image size is equal to full as well. So if I say like image size is equal to full. So this is like now the full notebook width image that will be displayed over here. Okay. So let's move forward and see. Okay. So next I want to show you about uh, handling and rotating and pan and zoom the 3D graphics as well. So in 3D, if you zoom over the mouse over that, so maybe let's have like a graphics 3D option of a cuboid. And now I'll also show you how different ways you can rotate this. So if when you see this cursor signs like two arrows, like a recycle sign, and if I move it, it will drag from the center of the graphic and it will rotate it into 3D. As long as these recycle type of arrows are coming, it will be rotating in 3D. But I can also have a 2D rotate of this image also. So if I click on the edges of the graphics over here, and you see now I have a different type of a graph, like a rewind sign is of a cursor key is coming. So now when if I drag and drop it, it's more like a 2D rotation only. This is not a 3D rotation. So once it is in the center, it will have a 3D because these are like two arrows joined together. But if I take it on the outer side of that, where it is a one arrow, now it will drag the edges of the graph and rotate them in 2D form. Similarly, I can also pan by pressing the shift. So if I press the shift key over here, you see now the cursor has a different shape, like 4 arrows coming in. Now I can pan this image into my while dragging it. So if I just want to show a portion of that, I can use the shift key and then I'll drag it within this pan to show the limited output. And similarly, if I want to zoom in, I can press the option key, and you see now there's a different type of cursor is over here. And when I move now this cursor, this will be like more like zooming in or zooming out of the image. So there are different ways you can resize your 3D images by having different clicking different options into that. So maybe another example of like a graphics 3D, and we take like a comb. So you can have your all resizing, rotation of the 3D images in this spectrum as well. Okay. So, yeah, this is very interesting. No, before that, I think I have another article maybe. Okay, so extracting data from graphics and images. Before that, I would like to show you some more things like on assembling the graphics and images as well. So maybe I'll just open a new notebook over here and I'll show something more over here, like assembling graphics and images. And the first thing which I want to talk to you is like how you can combine different graphs together. So that is very interesting sometimes, because you have different graphs and you want to show them together as well. So for example, let me take a example over here. I'll just copy this data so to make it more quick. So maybe I have like two plots. One is a bar chart and one is a list line plot. And I want to combine these two graphics into a single graphic. So we have a function called show. So if I can use just show function, and then I can use command L to get copy paste the input. So you'll see when I use this show command, the both graphs are now combined into a single graphics by doing that. One important thing to note over here is that when you do that, let me make a note over here, is the scaling of the first graphic is dominated. So is used or dominated. So whatever will be the scaling for the bar chart in this case, that will be used also to show this plot. And you can combine any number of graphics as well. So for example, maybe you want to have a graph of a disk or a circle or a rectangle and all shown together. So you can have the show graphic where you have the disk, the circle, and the rectangle all shown together into one graph. And then there are more features or the appearance you can add into the show function over here as well. So for example, you say, okay, I want to like have the frame of this. So you can have frame added to that. So this is adding a frame. Or you say, I want to label the plot. So maybe you say like plot label and just name it something like maybe an example. So as I mentioned, the first scaling will be normally dominated, and that will be used to represent the other. So the graphs elements may be clipped if you keep one graph first and then you keep the other graph separately. Let illustrate you that with an example. So if I have a show, and my first is a list plot, and that is like 2, 1, and 4, and then maybe I have another list plot, and the values for that is like 1, 2, 3, 4, 5, 6, 7, 9, 10 maybe. So you see when I do this together, let me make this list line plot so you can tell them apart. So you see some of the values from this second data points are not showing, and these elements which are like greater than 4 are not showing because this only goes till 4. So anything more than 4 is being clipped out of that. So in order to have that to be shown and represented, I need to make sure by adding like a plot range so that those values are not clipped out of that. And then I can give specific ranges of like x and the y as well. So I can say this goes to 0 to 10, and this also goes to 0 to 10. So now you see, now the whole plot range is available, and none of the element has been eliminated from this. Another way to show this or combine this maybe, so maybe take another example. So I'll show function, and within this I'll have this graphics and make a disk, and then maybe a plot of sine of x, and so you see this is how this looks like when the graphics is forward. Now let's see what happens if I put plot sign first, and put graphics back. So now it will be dominated by the scalings available in the plot, and you see it looks different. So that is why I said the options of the first graph that basically take over, and that take the things from here. But you can also give the locations for the elements in combined graphics to determine their coordinated value as well. So for example, you have a graph and a graphics. So so maybe we show the value. You see, I have the coordinates over here because now these are showing the exact coordinates like of the circle 0 and 0, and this is the coordinates for the line as well. But then I can use the overlay function to stack these graphics together on the same coordinates. So instead of having like a show over here, what I will do now is use another function which is called overlay. Overlay takes this and so overlay function, what will do, it will stack those graphics together based on their coordinates rather than just showing them on side by side. And this show function also works on 3D graphics as well. So for example, if I have a plot of a halifax and a sphere. So I've already written this for you to save time. So if I have these two plots of a halifax and a sphere, then I can use the show function on this and both combine the graphics of the halifax on the sphere. So this is one of the way how you can combine graphics is by using a show function and then using the overlay of that. Similarly, you can do the same things in images. Let's see how to combine images. So in images, what we can do, we have a function called image collage. So image collage will do is whatever your collection of images it will make a collage for that. So if you remember the image I use for the registration page and I use for my talks normally, those are all created using this image collection. So for example, if I have this 5 images over here of the I can use image collage, so it will automatically take those and make a image collage out of that. And then you can simply assign weights to the images. You say, no, I want this image to be much bigger than the other, so you can maybe assign the weight, that the weight of this is 10, maybe this is 4, and this is 1, and maybe this is 2. And this way you can assign the weights for different, or you can do image padding, and all those things are available over there also. So all those things you can use to combine images together. You can also similarly use overlay of an image with the second image as well. So for that we have a function called image compose. So if I have one image this and I have another image of that, and I want to overlay that, like in graphics we have a function called overlay. If you want to do the same thing with the images, the function is the image compose. And you can also like give the different values, or you can scale this also. Like for example, in the same option, if I say, okay, scale this and give certain values, like scale it to 3x4 and this also by 3x4. So you see this is now scaled a little bit rather than just on top of it, it is now scaled a little bit as well. So you can use image compose as well. Okay, so other thing which I want to show is how you can maybe insert one graphics into another also as well. So one way to insert one graphic to other is like just copy and paste it. So maybe if I have this sine of x and x goes from 0 to 20. So what I can do, I can just maybe right click it and I can copy the graphic from here, and then I can make another other graphic and then just paste it over there. So maybe my other graphics is so my other graphic is a rectangle of coordinates 0 0 and 1 1, and let me get this the plot range of 2. So I have this, and then I can double click on this graphics and I can just paste that thing over here also. So and then I can maybe, if I have to resize it, or I can move it around, and I can do that this way. I can also do this. So maybe sometime you are interested to develop certain things by doing that. You can also do that, but there are other and more better ways of doing that, but this is like one way of doing an inset function as well. But we in Mathematica, there's also a way, there's always a way to do this programmatically as well. So maybe we call this like the sine graphic, so that I can use it directly over here. So when I was doing this over here, so how I can insert that into that once I have written this graphics over here, I can have another and use another function called inset, and then directly have this sine graphic over here, and then I can give the destination point also, like which destination I have to do. So I say, okay, I want to give the destination of 0 and 0. And then I can also give the alignment point of the graphic, like what is the alignment point of the graphic. So the alignment is also 0, 0. And then what is the size of the inset graphic, like how I want to size this plot size also. So I can give all of those values programmatically. And now you see, rather than me copy pasting that, I can have those things. And if I change these values over here, I can have a different ways if I want to have. So what this basically is doing, this is giving the graphic inset function. So I am inserting a sine graphic. This is giving the destination point of the graph, 0 and 1 coordinates. This is giving the alignment point of that, so alignment for this, and this is the size of the inset graphic, what the size I want to do that. So you can also do that programmatically as well. So this is how you can combine your images and graphs as well. Let's go forward and let's look at the extracting data from graphics and images. And this is very interesting. I like it a lot because it helps me to, if someone is doing some image analysis on all those things, these are very interesting, how quickly you can get some data out of there and then utilize those data and keep that. So maybe if I have this image suppose. So let me go back to the working style, because then it will have the toolbar coming over here. So you see, when I do over here, I have this toolbar coming below this, which tells me what I want to do from here. And I can have like a coordinate tool over here. So if I click on this coordinate tool, what I can do is then I can just go into this image. And you see, whenever I move this, it is giving me the location and all those details. So if I click on some point, maybe this is my interesting point on this image. If I click on this, so there's a rod, and that it gives me what are the coordinates of this point in this image. Maybe there's another interesting point I want to see. This is another one. So this will give me the coordinates for that. So, and then these points are now added to the list. And then you see, you can copy, you can have tool options or all those things. They are normally in the page of, in the units of pixels with 0 and 0 at the lower left corner of the image. So it gives the X pixel and the Y pixels on this side. So if I copy them, so I copy as a marker image or copy as a coordinates or copy indices, I can do multiple things on that. So I can like copy coordinates from here. So now these coordinates are now available to me in my, and I can do that. So maybe I can say, okay, this is my image. So I say highlight okay, base look from. So this is my image, and then I say I want like image marker. And then these are my coordinates which I need to have image marker on, and then depending on what you want to do, maybe I want to say bullets, something like that. Okay, so highlight. Maybe I did a little bit syntax error, but what we can do, we can go into the documentation section and we can see image marker over here. So basically what it's gonna do, it's like circle bullet. Okay, so specify the, so you have images and then you get the coordinates, and then you can image mark those coordinates and give some types of things, how you want to do that. So you can highlight those things into that. If you remember, I showed this simple, these similar image processing things when I was giving a talk on neural networks, how the images in the crops are identified, where the attack of the insect has been done on those crops. So all these things, getting coordinates can be very useful on those image analysis. If you have images of coming from medical images or images from the farms, then you can utilize these image markers. Getting coordinates is very important. So you can get those coordinates directly into that and utilize that. Similarly, you can get the coordinates from the graphics as well. So maybe let me open a notebook over here. Let's zoom it a little bit. So maybe I have this Mandelbrot set plot over here, and then if I right click on this, you can see there's like a option called get coordinates. So I can click on get coordinates, and when I hover my mouse over this graphics, you see it gives me the coordinates on those specific things. In the similar way, where I have the images coordinates done for the images, in the similar way I can take the point. Okay, I can say I'm interested in this point and this point, and then I can take it forward and paste these coordinates into the expression and show something like that. Maybe I say let's take this plot again, and then I want to have like a graphics added into that, yellow and line. And in this line, what I'm going to do is give the coordinates. So what are these coordinates which I want to say over here? So maybe this, if this, suppose for example, this coordinate was minus 0.9 and 0.01. So let's take the coordinates. And maybe this is like minus 0.06 and minus 0.16. So I can just type in, or I can 0.06 and maybe 0.96, something like that. I hope I have not made a mistake out of that. Yeah. Okay. Oh, and then I can use a show function to show both of these together. And you see, giving the coordinates, I can have a yellow line coming from that coordinate to that coordinate. So in this way, you can have your graphics shown. Maybe these 2 points are more interesting. You want to have a line, or you want to have different way to represent that, that you can use and use that for the representation of this as well. Similarly, you can extract a region from this also. So maybe if you have any image and you want to take a region out of that, you can so maybe if I have some picture over here, and you see when I have this all the options below over there, and there is a mask tool over here. So if I click on this mask tool, more option comes in where it will tell me how I can use these drawing tools to mark the region you want to extract. So maybe if I choose a circle over here, and then I can have a circle drawn over here. So this is my select tool. Now I can have selected this region out of this picture. And then I can use this copy feature over here, and I can use it mask as an image, or take it as a graphic. So if I mask it as an image over here, now it is available into my clipboard. So if I paste it over here, so this portion out of this is now masked into that. So if I then do maybe computer region, like in this, I say, okay, image multiply. So basically what we'll do, it will take this image and multiply it with this image. Okay, this is a separate line. So you see this is now compute the region and paste it into an expression to evaluate. So now it's taking that only that region out of this. So I have all those masking features available over there as well. But I can also do this thing programmatically as well by selecting component and binarize that and writing the same code over there as well. So for example, if I have this image, and then I say, okay, I want to have maybe binarize this image. And then maybe I can use the select function to, or a select components function over here from the last output, and I say, okay, give me the count and count. Okay, so in this, otherwise it should have given me the largest white component of this there. Maybe this is the reason. Okay, now this is changed, so this will be minus 74. So this is basically giving me the largest white component of that, and then I fill in the black areas into that by using like filling transform at the last output. So this gives me the isolated black areas, and then I can use the small, then I can close up all these small articles by using like a closing function on this last output. Okay. So you can also extract the region by either programmatically or just by using those graphic tools and all those that. Those graphic tools are also interesting because it will also give you some options like doing some cropping and all those things. So if I go back to this image over here, you see a lot like a crop tool is available. I can crop the images, I can paint those. So a lot more features are available over here in this tool menu when you are dealing on and making the selection or extracting some value out of the images as well. So let's move forward and let's try to combine all of those what we have done up till now into a final touch, and then see how you can prepare your publications uh, with more quality and that. So let's open a notebook over here. Let me make it a little bit larger so we can visualize it clearly. So for example, if you have to make a simple uh, bar chart, so maybe let's make a bubble chart 3D, and let's have some values created automatically because I do not have any data over here. So I'll just create some random values, maybe 4. But you can have more appearances. As I told, we can have more appearances by adding plot theme, and then you can select all of these from here. And maybe in this my favorite in this is the solid grid. And then you can use some image sizing and styling as well. So I say, okay, with this, let's do some image styling over here. So all the styling goes into the next line. I'll say, okay, give me the label style. And you see all the fonts and the families have come in. How I want to have a label style of that, I can either select from here quickly, or if I am more interested and I'll have to give some specific value, I say, okay, no, I want a font family to be coming from the Times, and then I say, okay, the font slant should be italic, and I can do that. You see now when I hover, it's more like Times and it's in italic format. It is giving me the values for that. And if I want to have a specific image size, I can say, okay, like give me the image size. So every time someone uses that, it has a same image size over here. So I can have a specific reduce image size over here. So what this is doing is this whole is making the text times italic and in italic times and in italic font, and the image size is reducing the image size so that it is doing that. And then I can export this as well. So maybe just save this as chart variable. So the advantage of saving that into chart is now I can export this graphics. If I am not using Mathematica notebook and I want to use it into any other format like a notepad, or I want to use it into text environment, I can export this also and take it forward. So I can use an export command, and I say, okay, save it as a test.pdf file and save this variable. So now what it is doing, it will be saving this into a test PDF. And if I open this, so you see now this is available into my PDF file. So I have this now graphic imported into a PDF. If you want to save it into any other format like PNG, JPG, GIF, in any of that image, you can just give that specific command over here and you can do that. And then if you are using, you will use that use package or include graphics and give this file name over there, and it will take it forward from there. So plot themes provide a pre-packaged already, and they take it all of the charts and all the styles of that. So if you want to have and view how the different types of plot themes looks, you can have all those have together maybe. So the same thing, but the different, like having a classic, minimum, detailed, different types of plot themes are shown over here, and you can see, okay, which plot themes looks more appropriate in your case for developing and do that. And then of course you have the option of selecting the chart element function as well, as I told you earlier. So all you have to do is, once you have done that, you click here and then you go into the palettes, and then from the palettes you chart element type. So you select that, and then you can say, okay, this is a what type of bubble chart you are using, what types of options are available over here. Maybe you want to use a cube over here, it's a square, it's a solid. What's your temper ratio you want to have a shading or a fading one, and all those things, and you just insert it. So you can, maybe if you want to show a different angle to that, you can just manipulate or your image into that, customizing your charts into that, and you can take it forward from there. Okay, so we have already touched on resizing, how you pan your graphics, how much you want to show that, how you crop your images as well. You can do that as well. So I told you there is a cropping function available in the image also. So let's take another example, because if you have allow me, I'll take another example. So okay, maybe not this. So maybe I'll take the, let's open some let me show you how you can crop the images by programming into a given size or something like that. So there is a function called in Mathematica called image crop, and you just give it a picture to that image crop, and it will crop that picture for you. So it automatically trim the border, basically the image crop. But if you want to give up a specific size into that, you said, okay, you want to give some resulting image size, you can give over here, like this is the size I want my image to be, and the cropping fractions also you can give. So in this way you can crop equally on bottom and top, and this will be the resulting image after cropping. So maybe it's a little bit bigger in this case, maybe a smaller image will make more better sense. So I can crop this by giving the image size resulting, I want to use that. So maybe if this is my image, I can use like another function called image pad. So what does this image pad does is takes in the image, and then I can give the sides of those values, and those have to be that normally takes the negative values for that. So basically I'll get that value, so minus 100 to maybe minus 120, and the from the bottom, so this is basically left, this is right, this will be bottom, and this will be top. So this is how I'm going to say, okay, crop this from the left minus 100. So if I change this to less value, so this will crop that from the left. This is right, this is top, maybe crop a little bit more. So cropped a little bit more. Let's crop a little bit more here also from the top. So this is how you can give exact amounts of the pixel values of how you want to do that by doing that. And there's another function called image take also. Image take. So let's go and see image take does. So I'll open image take. So it also crop the functions, like take the first pixel rows of this image. So it will take the first 70 pixel rows of this image, or if you give the rows 30 to 100 and column 60 to 130 from the image. So a lot more details is available into the documentation center. Okay, so So I think that is most of the things I wanted to cover, and then we talked about crop and dart. So I'll maybe skip the 3D over here. What I'll give you an idea is if you go into the documentation center. So maybe like print 3D, and then you can see how you can directly make a 3D image over here, and then you can send that also to for the developer, and that so a lot more information on 3D image, how you can do that, how the model is created. So that will be that is another like maybe 30-40 minutes of thing. So maybe I'll cover that more in detail into my next session, where I'll dedicate it completely on how to handle 3D printing using Wolfram language, or how to develop the um, image which is ready for printing, so that you have to take all of those functions over here. Let me see how many functions are available in print 3D. So you see all of these things, like how to create the parametric plot, how to take the collections and importing the files into different models and repairing the model, finding the mesh defects and all those things. So what I have normally done is I have taken a small project and I'll take it from scratch to the end to send it to the final print. So I'll keep that for the next session, and I'll take it from there from that. So that is all for today. Let me take a quick look on the question and answer session. So what are the advantages of using Wolfram language for graphics and images? I think the biggest advantage of using Wolfram language is the flexibility. There are multiple ways you can do that. You have the drag and drop option. You have click and clickable options, and you can do all of those things in a programming format as well. So uh, I'll also share you my uh, email address. So if someone is interested to have a more detailed discussion on some topics, you can drop me an email uh, on my email address, and we will take that discussion uh, more on a more personal level, like what are your plans to do that and how you can do that in Wolfram language. And I'll be able to help you out or give pointers in the right direction. But the biggest advantage of Wolfram language is its flexibility. If you see my previous sessions as well, you can see it is used in different disciplines as well. We can use it for algebraic calculations, for symbolic calculation, for numeric, for image, graphics, sounds. So it's a huge it's a complete world in itself. So if you have any specific topics you want to discuss, or you think how you want to do that in Wolfram language, do drop me an email and we will take it forward from there. And thank you all for joining me today and staying with me. I know I've been a little bit more than 1 hour, but these topics are so interesting. Once I start going, it's hard for me to stop. So thank you everyone, and stay tuned for my next session. If you have ideas what specific topics you want to see or you want me to cover and give some tips and techniques, do drop me an email and I'll make some session on that. And if you have not subscribed to my session till yet or liked it, give it a big thumbs up and subscribe to my session. Thank you everyone. Have a lovely day. Bye bye.